semester is the database design from the conceptual design. So conceptual design does not require any specific computer science knowledge. So I think that you don't have to worry about too much. Right now, more important thing is your domain knowledge, whether you can analyze the information or to understand the requirement. So it's pretty much fun and you can enjoy it. And then usually I have a quiz at the specific chapter are done, completed. So, but this time some of the students are running late. So I will have in the middle of the class to have the quiz using code. I will explain how to do that. It's just a simple application for elementary level students. And then we will have the GCP lab on Thursday. Please bring your laptop, but not this room. So we are going to move to the Mandaville, the 104, the lecture hall, the biggest room in the Mandaville. It's the north side or the west side. Anyway, so you can find it easily. It's 104 because we have only the access point that allow up to only 30 students, 30 the access. But that room has at least 4 of them, so you are able to, all students are able to connect. So we are going to use the Google Cloud for your exercise lab. You need the MySQL, also the database project. So this time we will I will introduce what is the GCP for those who never used the cloud computing, and also we will set up the billing account. If you do not have the Google account, the individual Google account, not Bridgeport account, please create your Google account. I think most of the students have the Google account because the UB account is also based on the G Suite, so which is the Google account, but the IT service block the developer option, so you are not able to create your own virtual machine with that. So you can create a building, but that building account will not be activated. So please be careful to follow the direction. So that allowed up to the $50, but based on my experience, the $50 is not enough throughout the semester for some of the project. In that case, I will provide the extra coupon, but that will be the later problem. So please bring your laptop and connect to the. And also that room does not have enough power outlet, I think. So,
no, it doesn't have.
No, it's not like the demo.
No.
So please fully charge your laptop. It's just 20 to 30 minutes to activate your billing account. Any question before we start? Okay, so this is pretty much the first and last the handout. So what we so from the information here, so what we are going to do throughout the semester is design the database. So from the information here, so our goal is to create a database system where in the computer. So this one is not on the computer, it's just the real life. So from the real life, so our goal is to build a database, and this database is running on the computer system. And then at that time, definitely we need to use the software that is called the DBMS, Database Management System, that that is also based on the specific database model that also we are going to discuss about throughout the semester what kind of the database, the model we are going to use. Specifically, we are going to use the relational database management system, which is based on the relational database model. So, which means you need to understand what is a relational database model. But this is not just the one step, but it has several different steps. The first, what we are going to do is this is like a cloud. It's not well organized. What we want in the database, the system is more organized, well organized. So we are going to collect some of the important information. It's pretty much the data. Like specifically, we are going to find the entity and the relationship that we discussed today. So which is called the ER modeling. So it's a conceptual level modeling. So that conceptual level modeling does not require any the computer science or the technology skill. Instead, you need to understand the data domain knowledge itself. Okay. So because of that, many of the real projects actually ask such a conceptual level modeling to the domain expertise, like you heard about the consulting group. Okay. The standards and the PwC or the accounting group. So because they know the money flow and or the HR, okay, they do the conceptual modeling. Then the output among the bunch of different conceptual modeling. So we are going to use the entity relationship model. That is today's topic in chapter 3. Then this is not good enough to create a database. So we are going to adapt the database model. So that is the relational database model. It will be like this one. So it's a relation and the foreign key and the schema and so on. So this is the relational database model. So and the output of this one is the relational schema diagram. So finally, we can create a database using such a relational schema. So using this is called a physical database model, like how much the student table is the 100 megabyte, and the course database is the 1 gigabyte. So then they will be distributed. So physically, we are going to determine such a data structure. Then finally, we can create the database system using the SQL language. So we are going to learn how to use the SQL. SQL consists of the two parts, the DML and the DDL. So using the data definition language, we are going to create. Most of the SQL languages are very straightforward. So even though you never learned the SQL, you can easily understand. So it's a very high-level structured language. It's not a big deal to catch up. Then finally, we can create a table. You probably heard about the table, student table, or the transaction table. Then we can insert the data. So we have the database. Then the one more step is that this is the database to serve for the other applications. So we are going to create you are going to create the application program. Like for example, I'm going to use the web interface. So using the PHP, so can connect. Then the user interface is the web. So through the web browser, using the PHP, so we can connect the database and return the result. So this is the database system. So the final output of your project is the database system. This semester, we are going to implement the auction. So in the page 1, so you are going to define the project requirement, okay, which doesn't require any technical skill or the computer science skill. So focusing on what kind of the database system, the auction system you are going to implement. So today we are going to learn how to do the conceptual modeling. This is called the conceptual modeling. Okay. So for viewers, for throughout the semester, there's this room. This is almost a sweat. So I'm going to use the two sample database. One is the company database. Also, our textbook used both of them from time to time. So mostly the company database, but sometimes we are going to use the university database. So if you take a look at the second page, so there are requirements. It's a very well the organized, the formatted, the description about the company. After graduation, if you join the real project, so I think you never see this kind of the requirement. This is a full year practice. For example, the company is organized into the department that has the name, number, and the employee, and blah, blah, blah. So we are going to use this description. This is a kind of the project requirement that you are going to create in your page 1. Okay? In your page 1, if you build the auction database, you need to create this kind of the project requirement. In other words, so if you start your project after graduation, you join the project, then the first thing you need to do is you need to have a meeting with your customer. Then your customer probably asks, I need a database system for my company. Then you need to ask them what kind of information you are going to manage or keep track of in your system. Or your customer will probably give the files or some Excel file or some of the bunch of paper. Then these are the information that we are going to manage in our database system. Please design and create. Then you should analyze, understand such a requirement, create the requirement, that the design, the conceptual design. This is our goal of the chapter 3, the conceptual design. Okay, before we start, we need to take a look at the first page. So, easy. What we are doing today is this part, the conceptual design. Actually, before we, even though we do not use the database in our the programming class or any other project in computer science or IT, we already did the left-hand side. If you take a look at the left-hand side, the requirement, collection, and analysis. Think about, suppose that you have the programming assignment in your OP class. In your OP class, your instructor will ask, why don't you create a C++ application to manage the student information. Okay? Then, what is the first step? Creating database. So you need to define the class. You need to do the UML modeling. Okay, object-oriented. So the main part of the object-oriented programming is you need to understand the requirement and the data. You need to define your class, like the student class. Student can be the node, and the student has the name, ID, address, and we are able to access the student name or change the student name, such a behavior or the method you need to define. So that is called the functional analysis. So you already did the functional analysis. But based on such a functional analysis, you can, most of the time, what you have done in your application program is you use the memory-based database. Okay? In your memory, you eventually create the instance, the object. So you, in case of Java, using the new operation, you can create your object. Then you are able to access such a data. Then finally you can design your application, like the method or the behavior or the interface. Then finally you can create the transaction. This is what you have done so far. From the application, the process, developing process, we are going to take out the database part. Okay? For the database part, we are going to take out, then we are going to design for the database. At this time, we are not going to use the object-oriented programming concept. Instead, we are going to use the specific database model. Specifically, in our class, we are going to use the relational database model. To build such a relational database model, we need to, we cannot create if you remember that I raised, we cannot create the database model at once. Instead, from the information, we are going to little bit organize first. Conceptually, in my mind, I try to collect the collect all the database material here, and the operating system material here, and the big data material here. This is my conceptual design to organize my book. Then finally, we are going to buy the binder for the database. Another binder for the operating system, but I need a cabinet for the big data because it's too big. So this is the practical database, the design. So the first step is conceptually organize such information based on what? Requirement. However, one more thing we need to keep in mind is we need to work with functional analysis. So this is a common mistake when we start and when we are doing the conceptual design. So many of the designers or the programmer assume some of the requirements, like for example, the university has the student and the professor only. Okay, that is the experience, the common sense. But the first rule that we are going to apply is the requirement or the functional analysis from the information or the customer. If a customer wants to create the teacher, because in our university we do not have the professor, we have only teacher, then we are going to create the teacher, the database. Okay, so the conceptual design is always based on the requirement. In other words, throughout the project, so your phase one, the result will be kind of a guideline of the project. Also the GAME, when GAME will grade the project, it will be based on the requirement that you define in the phase one. So phase one is the requirement collection and analysis. And also sometimes there are different ways to design the database. At that time, we need to take a look at the functional analysis. If you remember the requirement of the phase one, I asked the realistic query in English. Okay, that is the kind of function, that is the kind of what you can do using your application, database application in your project. So then whether my design is feasible to the function. So you need to always consider the requirement as well as the functional analysis when you design your database. So probably throughout the semester, we will take a look at the many times of this one to make the better quality of the database design. So let's go back to our handout. So we are going to start right away the conceptual design. So in our conceptual design, we will use as I mentioned several times, the entity, the ER modeling. So first, for your reminder, what is the modeling? What is the model? It's a kind of standard. So for the data. So also the output of such a modeling is how can we standardize? It's a rule, constraint. So our goal of any kind of modeling is we'd like to specify the condition and constraint or the rules. That is our goal. So when we have the information, first thing is to vague. So it's not clear. We cannot create the database system directly from the information. We need to something massage or the organize. So first step for that, the organization. First step of the standardization. Well, first step of creating rule is we are going to find something, real thing. In other words, do you remember what is the data? Data is meaningful or important information. There are a bunch of other information, but we don't need this one. First, based on the requirement, we'd like to identify what is the meaningful information. In other words, what we are going to manage in our database. We don't need a feeling of the class. We don't need something the other. What I need from the class is how many students. And what is the grade? What is the major? That's what I want. Okay, similarly, from our company database. So first thing is we try to collect something, existing thing, or the important thing. That is called the entity. So entity is the real thing. So we are going to manage the real thing in our database. That makes sense. Okay. So first, to be familiar with the company database, so I'm going to read the description. The company is organized into department. Each department has a name, number, and an employee who manages the department. So it's a description about the department. And the department has several information. We keep track of the start date of the department manager. A department may have several locations. So while you are discussing with the customer probably explain about the company like this way. If you are lucky. If you are not lucky, most of the case, your customer will give something file, Excel file, or even the paper that has something the organization chart of the company. Okay, then you should be able to understand that this company has number of department, and each department you can see the something description, right? The department name and the manager information, start date of the manager, and so on. Then you should be able to identify the meaningful information about the company. So if you are lucky, so your customer provides such a detailed information, it's well organized, formatted information, so you can directly identify what kind of data will be entered. Most of the case, from the paper, from the information, or a bunch of files, you need to identify the such a thing. Okay. Then similarly, the second bullet, each department controls a number of projects. Each project has a unique name and so on. This kind of info. Similarly, your customer will provide the files regarding to the project. Then you should be able to identify that this kind of information are needed in your database. Okay. The third bullet, we store each employee's SSN, address, salary, sex, and the birthday. And also more details. Each employee works for the one department, but may work on the several projects. It can be kind of the policy or bylaw of the company. Okay. Sometimes you need to take a look at the bylaw of the company or the regulation or something. So sometimes it's undocumented, the rules of the company if the company is small. Okay, it's your job to identify. That is the reason sometimes most of the case, so such a conceptual design can be done by non-computer science. If you do not know what is the HR, it's very hard to understand the organization of the company, right? So, however, if you have the computer science knowledge, eventually our goal is to create a database system running on the computer. So if you understand the data structure, and also if you understand the domain information, it will be much easier. Okay, and also you will reduce something error or the mistake. Okay, the last one is each employee may have a number of dependents. And for each dependent, and we keep track of the name, sex, birth date, and the relationship to the employee. So this is kind of a Bible to build our database design. Okay? Even though you know much about the other information regarding to the general company organization, we don't care. We are not going to create. That is common mistake. So for example, in your midterm exam, I ask for the given information, why don't you create the conceptual design? Then one of the students create a really big the database design, including it can be applied to the real the company. That cannot be accepted. only based on the requirement, not the common sense, not your experience. Sometimes you can apply your experience, which is not identified, or which is not very clear. And also, even at the time, I strongly suggest to discuss with your customer whether this is the right or the correct. When I build this table or combine this table, one. Eventually, that will affect the performance when you launch your system. Okay, we will discuss that part in the normalization in the second half of the semester for better quality of the database design. Okay, so this is our thing. So first, our job is to identify the entity. So what is an entity? Entity is the real thing. It's a little bit confused. What is the real things? Why the Professor Lee say the thing? But I will explain later. So, but from this, the description, what can be the things that we are going to manage? What is really the important, meaningful, the things that we are going to create? So, for example, one of the example is the company is organized into departments, which means there are departments. Then the customer wants keep the information about each department, name, number, the manager of the department. Okay? So these are the information that the customer wants to manage in our database system, which means we need to create something that is called the entity. So first step of the database design is to identify the entity. Okay? So first example is the department. And any other things?
Project.
So next one is, what about the department name? Department name is a part of department. Okay? So sometimes it's not clear whether this can be the real thing or the entity, or this is a part of the entity. But this time it's very clear. Okay? That is the reason I mentioned you are lucky. Your customer is very well organized, then probably your customer understands the conceptual modeling. So it's for your practice. Okay, the next one is each department control a number of projects. There is a project in the company database, right? That project has a unique name, unique number, and also single location. So we can keep the project. Similarly, we store each employee. The employee has the number, address, the salary, sex, and the birthday. Okay? Then next one is the department already, and the subblock has we already identified the entity, and each employee may have a number of dependents. So these are the entities that we can identify from the company database here. I know there are more information in the company. Okay? Like for example, payroll office, which is not mentioned here. Okay? If not mentioned, we don't have to, because there is no data about the payroll office. Is there any other, the CEO information? No, there is no CEO information. So we don't have to create. Another common mistake is, what about the company itself? Company, is it the entity? It's actually entity, but it's only one. By combining all of this, it's kind of schema. Do you remember? The schema is the description of the data. All of this is for the company. If you have the number of company, one, another company in your group, okay? Then you can create the company entity. But here is only one, the company. That is the target, the schema. So we don't have to create the entity for the company. So these are the entities. For better understanding, though, we are going to use the diagram. Okay? So for example, to represent the entity, so we are going to use such a rectangular. So for example, the dependent is the entity. Employee is the entity. Project is the entity. Dependent is the entity, like this one. So if you identified any entity from your database description, we can use such a rectangular to represent it. So for better understanding, okay? There are different notation, so it's not standardized, okay? There's a code food notation, UML notation, many other, but we are going to use the one notation that is used in the textbook. But for your first exercise lab, probably next week, so we will use different notation. Okay, so I will explain later. But this is the one we are going to use. Okay, then one more thing. So we identify the entity. Very simple. So conceptual design itself is not very the complicated step. I always give the example of the organizing your dormitory room. So when you organize your room, so you have an idea. So nobody wants to separate the same information. Like I have the database handout, chapter 3, chapter 4. So chapter 3 is here, chapter 4. No, we try to collect. Okay, the similar or the same information together. It's the same idea. Actually, when we design the database, your customer will provide not like the well-organized information. Instead, they will provide something kind of this kind of. So for the department, HR. So HR, the name, and the HR is 111, and what other? So name, the number, and the manager of the department, the lead. Okay, start date is the January the 1st, 2017. For example, and this, the paper, 112, and the James, and February the 1st, 2016. And one more thing is the what other the department admin, 113, and Paul, and January the 31st of 2015. Like this, the information you can find from a file where the customer will provide this kind of information. Okay, then each of the data, the instance, is called the entity. Actually, this is actually real thing. Somebody may be confused. Why the department itself is the entity? It's not real thing. It's kind of a concept, right? Definition. Actually, real thing is when we identify the entity. This is the entity. That makes sense, right? This is another entity. And also this is another entity.